Hello year 9s, welcome back to Boyle's Law. So today's lesson we will be seeing what exactly or how exactly we can do the Boyle's Law experiment. So last lesson we saw what Boyle's Law is, we saw the equation for that, we saw how the graph looks like. Okay, so take a minute and think what Boyle's Law was. Who can remember what Boyle's Law is? Just say that to yourself. At a constant temperature for a given mass of gas, pressure is inversely proportional to volume. So when the pressure increases, the volume decreases. So when pressure doubles, volume becomes half. When the pressure goes down by a factor of 3, the volume goes up by a factor of 3. And what was the equation that we saw? PV is equal to a constant, or pressure times volume is a constant. Okay, so now in today's lesson what we are going to do is we are going to prove experimentally that pressure times volume is a constant provided temperature is kept a constant. So whenever you're doing Boyle's law, don't forget two things are constant: temperature and mass. Okay, so let's get going. So if we want to investigate Boyle's law, what are the things that we need? So Boyle's law is for a fixed mass of a gas, right? So we need some gas, we need something to measure its volume, and we need something to measure the pressure. So what you see on the board here is a very conventional general setup that we have for investigating Boyle's law. So this part that you see here, this is where you will get the volume of the gas from. This blue area here is the trapped air. And then, so this line that you have here will correspond to the volume of the gas. And then, how do you apply pressure is on this end. So it depends on the apparatus you're using. Sometimes you can pump air into it to change the pressure. Sometimes it is a sort of a pressing one. Instead of pumping, you press instead of pushing the pump into it, you press the pump and air particles go inside. So the apparatus will have some method of changing the pressure on the air inside. Okay, so this is the setup you need. And you can see in between air, here you can see that it is filled with oil. It can be oil or water. It is some liquid so that the pressure is transmitted uniformly. Okay, so we have a given volume of gas which is trapped in that cylinder that you can see. The end bit is sealed. A very important point, you need to keep the temperature of the gas constant. We will then apply pressure at the other end, and whatever pressure we are applying, you have a pressure gauge here. If you look at that, that will give you the value of the pressure. And as I said before, if you look here on this bit in the cylinder, you will get the volume also. And then we don't just do it for one. Normally we tend to do it at least 5, 6, 7 different values. Okay, so this is the experimental setup for investigating Boyle's law. So think that we did this experiment in the class and then we got a set of results as shown below. So we have taken 4 different values. Each time we checked what the pressure is. Say this is given in atmosphere. And 1 second, I'm just taking my pen. Yeah, so this is given in atmosphere, and say this is given in centimeter cube. Okay. They are not the standard units. Standard unit for pressure will always be Pascal, and for volume is meter cube. So this is what you have there. You have four different values for pressure, 4 different values for volume. And now what you need to do is pause the video and figure out the missing values for P times V. Okay, So pause the video and for the remaining three values, find out what P times V is. So copy the table first and then fill the gaps in. So remember to pause the video and come back. Okay, so I'm hoping that you have figured out the missing values, the other three values in the table. And when you figured out those three values, what did you see? You saw that the pressure times volume was staying the same. So we had constant temperature, we had the same mass of gas. So we saw that the pressure and the product of pressure and volume was the same. So this is what we call Boyle's law. So just a repeat of what our law is. For a fixed mass of gas at constant temperature, pressure times volume is a constant. Now, let's have a look at these results again. Now, let's see if a few other things we mentioned in the previous lesson is being followed here also. So we know that as pressure, so you can see as pressure is increasing, volume is decreasing. So that is fine. So that thing is being followed. Now we said when pressure doubles, it's going from 1.1 to 2.2. So pressure doubles. Let's see what's happening to the volume. It's going from 40 to 20. So what does that tell you? The volume is becoming half. So when the pressure doubles, the volume becomes half. That is exactly what we saw earlier. Not only doubling and becoming half, let's just pick two random values not without too much of an exact ratio. It's going from 1.1 to 2.6. I'm going to check what ratio it is. 2.6 divided by 1.1. So 2.36 recurring. So this is 2.36 recurring. So from 1.1, when the pressure is becoming 2.6, it has increased by a factor of 2.36 recurring. Let's see what has happened to the volume. 40 became 17 means perfect. It has also gone down by a factor of 2.35, which is almost the same. Okay, so when pressure increased by a factor of 2.35, volume went down by a factor of 2.35. Okay, so yes, we did notice that when P doubled, V became half. So which means if whatever happens to P, the opposite happens to V by the same factor. Or this is what we summarized as volume is inversely pressure proportional to pressure, or pressure is inversely proportional to volume. Now, what I want you to do is plot a graph. Plot a graph for the results you got. Now, while you're plotting the graph, I want you to pause the video, plot the graph, and then come back and look at the last slide to see if you have received the 4 marks. Okay, so I'm not telling you what the 4 marks are for. Think. When you're drawing a graph, what are the sensible things we should see on the graph? Think that, look at the table, pause the video or take the presentation back to where you have the table shown, pause it there, draw the graph and then come back to this. Okay? And don't forget, draw the graph only with a pencil. You need a pencil, you need a ruler. But then the 4 marks are not for any of those things. Huh? You need a pencil, you need a ruler, you need a rubber. That is there, but the 4 marks are not inclusive of those things. Get those 3 things if you don't have it with you, and then start drawing. Okay? So all of you have drawn the graph. So let's see how many marks you are going to get for your graphs. So 1 mark is for having your x-axis labeled with units. So pressure along the x-axis and the unit. You can put any unit for pressure you want, but on the table initially we added ATM, which is atmosphere. But if you want, you can go for Newton per meter square or Pascal, it doesn't matter. And then your y-axis with units again. So on the y-axis we had volume, and the unit is ideally meter cube. Can go for centimeter cube also, no problem. Now the next, but one of the most important thing that you do is the scale that you choose for the graph. And when I say the scale you choose for the graph, say you went up in say 0.2, 0.4, 0.6, okay, whatever scale you're choosing, the plotted points that you have should cover more than half of the graph paper. Now what does that mean is, sometimes what happens is students have say values after, say they have the values from let's say from 2, then it goes to 2.2, 2.4, 2.6. These are, say, I'm not taking it with the last values, I'm just picking 4 random values. And when they plot the graph, what they generally do is they go for 0.5, 1, 1.5, 2, 2.5, and 3. But in this case, what happens? You're not going to use any of these area because your plotted point starts only from 2. So they say you went to something like this. So you're using only this much of your graph paper. You're not using this much of your graph paper. So when you choose a scale, so this tells you that this scale is not appropriate. So you need to have another scale. Okay, so like that, the plotted points should cover more than half of the graph paper. That is very important. There is marks for that. So use your graph paper. When you're using your graph paper, make sure the points are widely distributed. And the last mark is for a thin, smooth line. So some kids have a habit of drawing the lines like this. Looks like some hairy structures. Okay, we don't need that. This is wrong. You need to have a thin, smooth line or a thin, smooth curve. You don't need to have a really, a blunt pencil and then you go down like this, then something like this. All these things are not allowed. So it has to be a thin, smooth line. So if all these things are there, then you get 4 marks for your graph. Okay, and another thing what generally we see is when students have a big graph paper, so say you have been given a graph paper of this size, I don't know why, but for some reason some students prefer to draw a small graph like this at the corner of the page. Please don't do that. Okay, your graph should be going from, as I said, when you're drawing, you should try to see that it cover more than half of the graph paper. Is that clear? So this is how you get the 4 marks for drawing the graphs. Now I have also mentioned which are the questions you need to do. Once you have gone through the PowerPoint, made all the notes you need, drawn the graph, then make sure you have done the workbook questions which I have mentioned in the frog or in the email that I have sent you. Okay, so see you next lesson, and if in that lesson if you have any doubts on Boyle's law, you can ask me then. Okay, bye bye.